Hi everyone, you're watching Video Notes 2.2, and I know that some of you are having a hard time and not really liking watching videos, so I started with a really cute picture of Hazel Hayes. She's my dog, and she might be cuter than Miss Russio's dog, but all dogs are equally cute. So this is Mrs. Hayes, and we are doing 2.2 function notation notes. I know you guys learned a little bit about functions in the middle school, but let's see what you remember. Functions are rules that take inputs and convert them into outputs. So the output is nothing more than saying f of x, as if you applied the function to the input. So like a machine, the input goes in, you apply the rule, whatever the function rule is, and the output comes out. I call the input x and the output y. If you remember, in a table form, x, y, so x would go in and y comes out. That's the function. All right, let's try a few notation things here. For each of the following functions, find the output for the given input. So they gave me a rule. This time it says 3 times a number plus 7. So we're going to take 2. This is an example with 2 plugged in. This is nothing more than substitution. So I subbed in the 2. And I got out 13 after calculating. Now I'm going to do the function with -3 plugged in. So I'm going to apply the rule 3 times the number plus 7. And the number is -3. So I calculate -9 plus 7 is -2. That's my output. -3 was the x value or the input, and -2 is the y value or the output. Then they gave me another rule called g of x. That's just the name of the function. And the rule is take a number x, subtract 6, divide by 2. Here's an example with 20. 20 take away 6, divide by 2. You get out 7. Let's do it with 0. 0, usually I use parentheses, just in case we have a negative. That keeps everything calculated the right way. So really I have 0 minus 6 and divided by 2. So the g of 0 gave me -3. The input was 0, so this is x, and this is y. Next rule I have is for h of x. It tells me to do 2 times a number plus 1 and take a square root. So I'm going to put a 4 in, calculate it, and get out a 3. Now we're going to do this with a 0. We're taking the square root of 2 times the 0 plus 1. So my input was 0 here. If I calculate, the last thing I'm going to do is take the square root. 2 times 0 is 0 plus 1. That's the square root of 1, and that happens to be 1. You can always use your calculator to help you do the calculating, but really you're just doing substitution and then you're evaluating. Substitute the value in and then evaluate. Exercise 2. Given the function f of x equals a number divided by 3 plus 7, do the following. F of -9. So we're substituting in -9. -9 divided by 3 plus 7. Our number was -9. We do the math. That's -3 plus 7, and I get out a 4. So this went in, -9, and that came out. So f of -9 is equal to 4. Find the input this time. I'm looking for x. They gave me the output was 13. So when I look at the rule, I'm going to rewrite it. F of x equals x over 3 plus 7. F of x is 13. So this output is 13. I am trying to find x. This is like solving an equation. Because it is. Not like it. It's exactly what we're doing. So I'm going to subtract 7 over to the other side. I get 6 equals x over 3. And then I'm going to multiply by 3 to get rid of dividing by 3. my final answer will give me 18. So the input would be 18 if the output is 13. So if I put 18 into this function, 18 divided by 3, 6 plus 7, yep, I'd get 13 out. Exercise 3 is a word problem, but don't be scared. So they gave me boiling water at 212 degrees Fahrenheit is left in a room at 65 degrees, so that's the room temperature, and it cools. Temperature readings are taken each hour, so these are the hours. That's like the input or the X value, and the output is the temperature. In this scenario, the temperature T is a function of the number of hours, H. So it's a function of the hours, which means as the hours go on, you get out different temperatures. 0 hours, there's your original temperature. 8 hours later, there's the new temperature, 65 degrees. Evaluate just means find the value of T of 2. So that means if my H, because remember this is a function of H, right? That's like my X value right now. If my X value was 2, which is right here on my table, my capital T temperature would be 104. So T of 2 is 104. It asked me another question, T of 6. T of 6 from the table is 68. These are both degrees Fahrenheit because they're my temperatures. And those are the two answers. Part B, for what value of H is T of H 76? So now I want my temperature to be 76, and I want to find the value of H. And H would be 4. That's hours, 4 hours. Just using the table. Between what two consecutive, remember that means in a row, hours, will T of H equal 100? So remember that this is cooling, 141, 104, and then it's 85. So 100 falls between the second and third hour. Explain how you found that. Between hour 3, oh, I meant 2, and 3, the temperature cooled, or you could say went from 104 to 85. It cooled to 100 between there. So the temperature dropped from 104 degrees to 85 degrees, so that took between 2 and 3 hours. Sometime in that time frame is when we reached 100. On to the next page. Exercise 4. The function is defined in the graph below. It's a piecewise linear because it's made up of straight line segments. So line, then a different line, then a different line, then a different line. It gave me 0 right here. 1, 2, 3 goes that way. 1, 2, 3, 4. We're going to ask some questions now. Evaluate each of the following. F of 1 would be 4. That means when x was 1, we found the y value to be 4. If you look at the graph, it's the big red dot at 1, 4. This one's asking when x is negative 3, so on my graph, negative 3 would be right here. Go down to the function, and that point is negative 3, 1, 2, 3, 4, negative 4. Now I'm looking for f of 5, so go over to 5, and my function is down here at negative 2. So when x is 5, my y value was negative 2. That's all they're asking for. 0 goes up to a y value of 2. There's a point on the graph, 0, 2. That's another way to look at it. I was looking for the output. Solve each of the following for all values of x that make it true. So now I'm looking at a y value, and it wants to know what x values. So what I would do is go to a y value of 0, which is this blue line that I'm drawing on the graph. This is where y equals 0. And look and see where we cross the function. That happened at negative 1, and it happened again at 4. wait a minute, and it happened again at 7. So it should have happened at -1, 4, and 7. So those answers aren't quite right. The function is 2. I'm going to draw a blue line at 2. There's a dotted line already here. Dotted line at 2. And my function that happens when x is 0. It happens again when x is 3. And that's it. That must have been what she thought she had the answers filled in for. All right, now let's look at -4. So I'm going to go down to -4, and I'm going to draw a line. This is where y equals -4. It hit the function over here at x equals -3. I'm going to draw another line up at 4, and it hits the function at x equals 1. What's the largest output achieved by this function? At what x value is it hit? So the largest output is 4, and that hits at 1. It's the highest point on the graph. Largest output, 4, x value, 1. It's the highest point. Rewrite each of the following using substitution. So the first two are done for you. You can look back at those as you need to. This one is telling me to do -2 times g of x, which is x squared plus 6x. You're just replacing the function with the rule that they gave us for the function. That's all you needed to do, but you could also distribute and clean it up. -2x squared minus 12x. And then d, 5 times the f function, which is 4x minus 1, if you look up here, minus g of x. I'm using parentheses because I'm subtracting all of this. Distribute the negative, distribute the 5. 20x minus 5 minus x squared minus 6x, and then I can put them in order. I always put the highest power first, combine the x's next. That's a 14x, and then I have a minus 5. You did not have to do that. This was your answer right here. All right, that concludes the notes, and have a great night.